Unbelievable! A star appears to have approached Earth closer than the Voyager probes. In an astonishing revelation that has taken the astronomy community by storm, scientists have reported the discovery of a star that seems to have approached Earth closer than the Voyager probes, the furthest human-made objects from our planet. This news has sparked excitement, debate, and even a bit of disbelief, as it challenges our current understanding of stellar motions and space dynamics. For decades, the Voyager 1 and Voyager 2 spacecraft, launched in 1977, have been venturing into interstellar space, becoming the symbols of humanity's quest to explore the far reaches of our solar system and beyond. But now, the idea that a star may have ventured nearer to Earth than these legendary probes has raised a wave of questions, speculations, and thrilling possibilities. Voyager probes, humanity's longest journey. Before diving into the extraordinary discovery of a nearby star, it's essential to revisit the significance of the Voyager missions. Launched over 45 years ago, these twin spacecraft were designed to explore the outer planets of our solar system and then continue their journey into interstellar space. Voyager 1 is currently over 23.3 billion kilometers, 14.5 billion miles, from Earth, while Voyager 2 is not far behind at over 19.4 billion kilometers, 12.1 billion miles. Both probes have long since completed their primary missions of exploring Jupiter and Saturn, and in the case of Voyager 2, Uranus and Neptune as well, and they now represent humanity's first steps into the vast, unexplored regions beyond our solar system. The Voyagers have been transmitting invaluable data about the heliosphere, our solar system's protective bubble, and the environment of interstellar space. For years, these spacecraft have held the title of the furthest human-made objects from Earth, venturing beyond the boundaries of the influence of our sun's solar wind. Until now, they were thought to be the closest tools we had to understanding what lies between us and the distant stars. But with the recent report of a star seemingly approaching closer than these probes, the Voyager's status as the ultimate travelers has come into question. A close encounter. The discovery of a star nearer than Voyager. The discovery of this stellar body is truly remarkable, not only because of its proximity but also because such an event is incredibly rare. Stars, as we know, are constantly moving through space, carried along by their own momentum and the gravitational influence of other celestial bodies. While stars have passed relatively close to Earth in the distant past, the current discovery suggests that one may have approached within a distance shorter than that currently traveled by the Voyager probes, marking a close stellar encounter that hasn't been observed in modern times. Astronomers believe this star could be a rogue star or a member of a nearby stellar group, whose trajectory has brought it surprisingly close to our solar system. Initial observations suggest that this star is small, possibly a dim red or brown dwarf that wasn't easily detectable with traditional telescopes. While it hasn't yet passed within the solar system itself, its proximity is nevertheless closer than any other star currently known, and its approach toward Earth has ignited a wave of scientific inquiry. How can a star be closer than Voyager? One of the first questions to arise from this discovery is, how can a star appear to be closer to Earth than the Voyager probes, given their incredible distances? To answer this, we need to consider both the relative positions of celestial objects and the complex motions that govern our galaxy. While Voyager 1 and Voyager 2 are moving away from Earth at high speeds, about 17 kilometers per second for Voyager 1, they are still within what is considered the local neighborhood of our solar system, though they've crossed the boundary of the heliosphere. Stars, on the other hand, are much further away in most cases. The nearest known star system to Earth is Alpha Centauri, located approximately 4.37 light-years away, which is about 41 trillion kilometers, 25 trillion miles. However, if a small, dim star such as a red or brown dwarf were to pass through the outer reaches of the Oort cloud, the spherical shell of icy bodies that extends far beyond the orbit of Pluto, it could conceivably come within a distance that rivals or even exceeds the distances currently traveled by the Voyager probes. For perspective, Voyager 1 has only just crossed into interstellar space, and it remains relatively close to the Sun in astronomical terms, still within about 0.002 light-years. A nearby star could easily approach within this distance, especially if it's part of a dynamic stellar system or a rogue star ejected from its home galaxy or cluster. The implications of a stellar encounter. If a star has indeed passed closer to Earth than Voyager, The implications are profound. First and foremost, this discovery would challenge our current understanding of the dynamics of nearby stars and the long-term gravitational interactions between the Sun and the stars within the Milky Way. Such a close encounter could have significant effects on the Oort cloud, potentially disturbing the orbits of icy bodies in this distant region and sending some on a trajectory toward the inner solar system. In fact, many astronomers speculate that previous close encounters with passing stars may have triggered comet showers in the past, possibly leading to impacts on Earth and other planets. While this newly discovered star is not expected to have any immediate impact on our solar system, its proximity raises the possibility of similar stellar flybys occurring more frequently than previously thought. Furthermore, the discovery highlights the need for more extensive searches for nearby, dim stars, particularly rogue stars and brown dwarfs, which are often difficult to detect due to their low luminosity. These objects may play a more significant role in shaping the long-term evolution of our solar system than we realize. What type of star approached? Early observations indicate that this star is likely to be a red or brown dwarf, a type of star known for its low mass, low temperature, and dim light. Brown dwarfs are often considered failed stars, as they do not have enough mass to sustain hydrogen fusion in their cores, the process that powers most stars, including our Sun. Instead, brown dwarfs shine dimly due to the heat left over from their formation, gradually cooling over time. Red dwarfs, on the other hand, are small, faint stars that can sustain fusion but burn their fuel so slowly that they live for billions or even trillions of years. While these stars are difficult to detect over large distances, they are among the most common stars in the galaxy, making them likely candidates for nearby encounters. Because these stars emit very little light, astronomers rely on infrared telescopes to detect them. Webb's unprecedented infrared sensitivity has played a critical role in this discovery, allowing scientists to track the star's approach and calculate its distance with high accuracy. Without this technology, this star might have gone unnoticed, even though it had come closer to us than any star in recent history. How was this star detected? The discovery of this nearby star would not have been possible without the cutting-edge instruments on modern telescopes, particularly space-based observatories like the James Webb Space Telescope, JWST. Unlike optical telescopes, which rely on visible light, infrared telescopes can detect the heat signatures of faint objects like brown dwarfs and rogue stars that are too dim to be seen by the naked eye. In this case, astronomers first detected the star using data from infrared surveys of the sky. Follow-up observations confirmed that the object was a stellar body, and careful analysis of its motion suggested that it had passed closer to Earth than any other known star. This discovery also underscores the importance of continuous sky surveys. As technology improves, we are increasingly able to detect objects that were previously invisible to us. The fact that a star could approach our solar system unnoticed for so long demonstrates the need for ongoing observation and monitoring of our cosmic neighborhood. Could this star be a threat to Earth? One of the first concerns raised by the public following the announcement of this discovery was whether this nearby star posed any threat to Earth. While the idea of a star approaching so close to our planet might sound alarming, astronomers assure us that there is no immediate danger. The star has already passed its closest approach to Earth and is now moving away, and its gravitational influence is not strong enough to have a significant impact on the inner solar system. However, as mentioned earlier, the star could have disturbed objects in the Oort cloud, potentially sending comets or other icy bodies on a long, slow journey toward the inner solar system. These objects take thousands or even millions of years to travel inward, so any effects of such a disturbance would not be felt for a very long time. Moreover, the discovery of this star highlights the broader question of how often such close stellar encounters occur. While this particular star is not a threat, future encounters with other stars could have more significant effects, particularly if a larger or more massive star were to pass through our solar system's outskirts. What's next for research on nearby stars? The discovery of a star passing closer than Voyager will undoubtedly inspire further research into the dynamics of nearby stars and their potential influence on the solar system. Astronomers will continue to track the star's motion to learn more about its origin, trajectory, and possible interactions with other objects. Additionally, this event emphasizes the importance of expanding our search for dim, hard-to-detect stars and brown dwarfs. These objects are far more common than we once thought, and their proximity to Earth means that they could play a more prominent role in shaping our cosmic environment. In the coming years, new data from space telescopes like JWST and ground-based observatories will help scientists refine their models of stellar dynamics and provide a clearer picture of the stars in our galactic neighborhood. These discoveries will also offer valuable insights into the history of our solar system, including the possibility that past stellar encounters may have influenced the formation and evolution of planets, moons, and other celestial bodies. A stellar wake-up call. The revelation that a star has passed closer to Earth than the Voyager probe serves as a powerful reminder that our solar system exists within a dynamic, ever-changing galaxy. While the stars may seem distant and unchanging, they are constantly moving, interacting, and influencing one another in ways that we are only beginning to understand. As technology continues to advance and our ability to observe the cosmos improves, we can expect more surprises like this one. Each new discovery brings us one step closer to understanding our place in the universe and the forces that shape the cosmos. The discovery of a nearby star passing closer than Voyager is not only a testament to the incredible capabilities of modern astronomy, but also a call to continue exploring, learning, and pushing the boundaries of our knowledge. Whether it's through the Voyager probes, the JWST, or future missions, humanity's quest to understand the universe is far from over, and there are still countless mysteries waiting to be uncovered.